Welcome back, Leo Lions. This is Mrs. Morkin with today's lesson over factoring a GCF. So just as a heads up, we will be taking a quiz over multiplying polynomials. But because there have been so many e-learning days, we are moving on to factoring. So factoring is basically the opposite of everything that we've been doing. We've been multiplying a monomial times a polynomial, binomial times a binomial. What we're going to do now is take the product and go back to the actual expression that we started with. So just a quick warm-up on what we have been doing, the actual multiplying a polynomial. So this first example, we took a monomial a and multiplied it, distributed to both terms inside the binomial. So we would get 3a squared plus a times 7, so plus 7a. And we couldn't simplify any further than that because those are different terms. Same thing, next example, we would distribute a negative 2m, and we are distributing it to all three terms this time. So negative 2m cubed minus 12m squared, and then negative times a negative, so it'd end up plus 12m. Next one, we would distribute this longer monomial, so 4x cubed y, we're going to multiply by that binomial. So 4 times the coefficient is 1, so it stays 4. X cubed times x squared, we get x to the 5th, and then there is a y, no y next to that y squared, so just stay y. Minus 4 times 2 is 8, so multiply coefficients. We add the powers that are on the variables unless there is just one, like the x cubed. There's no x in that 2y, so it just stays. And then y times y, so minus 8x cubed y squared. All right, so that's just a refresher on what we have been doing. We've been distributing and multiplying polynomials. So next one, and I just realized up here that this should be 2m, not 12m. There we go. Some of you probably already caught that. So next step, what is factoring? So what we just did is when we multiplied that out, for instance, that 3a squared plus 7a. So that, for example, I'm looking at that first example at the top. That is in simplest form. We can't combine those. They don't have the same power. So that's as far as we can go. Now, the factored form is actually what we started with, the a out in front of the parentheses, and then that times the binomial 3a plus 7. So that's what we call the factored form, and then when we multiply it, we get the simplest form. So polynomials, when we go to actually factor these, some polynomials can't be factored, so if they can't be factored, we call these prime. Okay? So, several methods says here that we are going to factor by. The first step in any polynomial that we are factoring is to always start out with the GCF. Is there a greatest common factor between all the terms in that polynomial? So in order to do this, step 1, we're going to identify the GCF of the polynomial. So you want to look at the coefficients. So those are the numbers in front of the variables. Or that number in front of the variables, and you'll look for a GCF, so the greatest common factor. Then you're going to look at the variables. A variable has to be present in all terms to be a GCF. And then if it is present in all those terms, then you want to take the one with the smallest exponent. After you do that, so you pull the GCF out in front of the parentheses, and then step 2, you're going to divide all of the terms by that GCF and leave what is remaining in the parentheses. So for example, our two terms in number 1 is 3x and 12. So you want to look at the coefficients. The coefficients are 3 and 12. So the greatest common factor between those two is 3. Remember, factors are what can you multiply by to get that 3. So 1 times 3. 12 is 1 times 12, 2 times 6, 4 times 3. So the greatest common factor they have is 3. So what you do is you pull out that greatest common factor, and I immediately write down my parentheses, because then what's going to happen is we're going to divide both this 3x and the 12 by the greatest common factor. So 3x divided by 3, the coefficients then, that would be 1. Now we'd be left with an x, so we could write 1x, but 1x we can simplify to just x. 12 then we will also divide by 3, so that would be the whole number 4. Now, when you are done, you can always check your work when you are factoring. So if we went off to the side and distributed that 3x and the 3 to the x and the 4, we'd get 3x plus 12, and you want to make sure it always goes back to what you started with, which it does. So we know the factored form of 3x plus 12 is this 3 times the quantity of x plus 4. Okay, I'm going to jump straight below it. So again, our first step, look at your coefficients. So 8 and 36, that is not 36. And what you could do if you had no idea, actually I'm going to stack these, you could list out those greatest common factor, but hopefully you will start getting the pattern of this and be able to list or be able to find the GCF without listing them out. So 1, 2, 3, 4, then 6, 9 times 6, sorry. 6 times 6 is 36, 9 times 4, kind of thinking backwards here, 12 times 3, 2 times 18, and 1 times 36. So this is a way just to find the greatest common factor, which would be 4. So we pull 4 out in front, and I immediately am going to write down the two ends of the parentheses. So now we divide 8m by 4. 8 divided by 4 is 2. We're not dividing by a variable, so the variable stays. 36n divide by 4, so we get 9 and n. And I guess I skipped after I found that GCF 4, you do always want to look then at the variables. If those were the same variable, then we could pull that variable out as the GCF as well. In this case, it was m and n, different variables, so that did not come out in the greatest common factor. So again, I am going to distribute the 4 to see, does it go back to what we started with, 8m plus 36n, and it does. So I know that this is the factored form. And I'm erasing those just so I'm not confusing you into the end. So there's our factored expression, okay? Again, 7y minus 7. So the greatest common factor between those is 7. They do not both have the variable, so there's only a number we can pull out as a GCF. 7y divided by 7 is y. 7 divided by 7 is 1, and there's a negative in front of it, so negative 1. And we could distribute it back. We'd get 7y minus 7. And 5 and 30, so our GCF would be 5. We look at our variables, x and y, they are different, so we cannot pull out a variable with that GCF, so I'm immediately going to write down my parentheses. Then we want to divide 5x by 5, so we'd get 1x, or x. 30y divided by 5, so we get 6y. And then distribute it back, we'd get 5x plus 30y. So we know we are correct. All right, those are those examples on that side. Now let's keep going because I want to make sure we get to one where we have a variable as a GCF as well. So I'm going to keep going down the left side like I've been doing. So 6 and 27, GCF would be 3a squared, but 27 does not have a variable, so 3 is the greatest common factor. I'm going to write down my parentheses. Now divide both terms. So 6a squared divided by 3, we get 2a squared. 27 divided by 3, we get 9. And then distribute the 3 back. So we'd get 6a squared plus 27, which is what we started with. We know we're correct. Right, next one, we are finally going to have one with a variable in our GCF. So look at the coefficients, 21 and 3. The GCF of that would be 3. Now, they both have the variable d. Now, there's just one d, so we are going to pull out the variable d with our GCF. So 3d, and then we are going to put our parentheses down. Oops, and then same process, we are going to divide both these terms by 3d. So 21 divided by 3 is 7. Now the variable cd divided by d, that's where we get those variables cancel out to 1, so all that would be left is c. All right, we're subtracting exponents here. And then 3d divided by 3d, they're the same on the top and bottom, so it just simplify to 1. And we could distribute, we'd get 21 CD, and then we distribute to the -1, we'd get minus 3d. So we know that is correct. Next one, 15 and 30, our GCF is 15. We have several variables in common here. We have a squared and a. So remember on the front side it said if they have the variables in common, we take the smallest power. So the smallest power would be a. The second term only has one a. The first term has two a's, but it has to be the greatest common factor. So there's only one common a. Then the second variable, b, we have a b and a b, so the GCF also includes the b. So 15ab is our greatest common factor. Then I'm going to set up my parentheses. 15a squared b divided by 15ab. So 15 divided by 15 is 1. A squared divided by a, so we'd subtract them, we'd have one a left, and b divided by b is 1, so those would cancel out. Then 30 divided by 15, so minus 2. A divided by a, those would cancel out, and then b divided by b, those would cancel out. So I'm actually going to scoop my parentheses a little closer here. And then I'm also checking kind of in my head on these. So 15ab times a, we'd get 15a squared b, which is what we had. And then 15ab times -2, we'd get minus 30ab. So I checked my work just to make sure that it does go back to my original expression. Variables only, so no coefficient. So the coefficient is 1 in these, so the greatest common factor would be 1. Now they do have a variable a in common, so the greatest common factor would be a. Not b, because b is not in the second term. Then ab divided by a, those a's would cancel out, we'd get left with b. A divided by a is 1, so b minus 1. And I guess that a is huge, so I'll make it a little smaller as my b. So if we distributed, we'd get ab minus a. All right, I want to get to the next one. So 5x minus 13y, if we look at those two terms, 5 and 13, there is no GCF in those. They're both prime. So 1 is the greatest common factor. X and y, those are different variables, so there's no variable in common as well. And you don't want to pull out a 1 because you'd wind up with the exact same thing in your parentheses, and that's not really helping you factor it. So in this case, when there is no GCF between the coefficients and the variables, then we say that this polynomial is prime. We cannot factor it. Okay? Going to keep going where we have 3 terms, just do a couple more here. So now we have to find GCF of all 3 terms. So now looking at the coefficients, 2, 2, and 4, so the GCF would be 2. Now look at our variables. We've got x squared, x, and x. Take the smallest power, so just x. And then we also have y, y squared, y. Again, take the smallest, so just y to the first, or y. Then we do all 3 terms divided by 2x. So 2 divided by 2 is 1. X squared divided by x is, we have 1x. And then y divided by 1, they cancel out. Minus 2 divided by 2 is 1. X divided by x, they cancel out. Y squared divided by y, we get left with y. And last one, 4 divided by 2 is 2. And then x divided by x, y divided by y, those all cancel out. So we'd get left with that. And again, check your work. 2x squared y minus 2xy squared, and then plus 4xy. It does distribute back to what it was. I'm going to do one more simply because this one has higher powers on your variable. So 6, 14, and 10, the highest GCF for those would be 2. Then we have y fourth, y to the third, y squared. So they have a y squared. Take the smallest power. They only have 2 y's in common. That's the most. So we pull that out front, and now we divide everything by 2y squared. 6 divided by 2 is 3. Y squared divided by, y to the fourth divided by y squared is y squared. 14 divided by 2, so we get 7. y cubed divided by y squared, we get 1y left over. And 10 divided by 2 is 5. Y squared divided by y squared, they cancel out. So distribute it back. 6y to the 4th plus 14y cubed minus 10y squared. It works out. So if you check your work, you should know if you're getting these correct or not. There are several that you can try on your own now, so I'd like you to pause the video and please try to find the GCF, pull it out in front of the parentheses, and then divide each of those terms by the GCF. Check your work in the end to see if you're on the right track.